Alright, so welcome to the session, and I hope all of you guys are doing good. So let's get started with today's session. So we'll start with the first question here. The daily task and challenges which you guys will face and all, we'll discuss that once we are ready with the interview, right? Once your resume will be ready and all those things, after that we'll discuss. As of now, I have to take all of your interviews as well, DS12 batch, right? So mostly we'll schedule next week and we'll check what is the status, how well you are prepared, then we'll proceed further with resume building and all those things. Let's be ready for the interview. I think we will start from the week of 26 for DS12. All right, so let's start with the session here. We'll start with the first question. RailQ, a smart transportation analytics provider, wants to optimize platform usage at busy train stations, reduce delays and congestion. Given a day's schedule of train arrival and departure times, determine the minimum number of platforms required to accommodate all train traffic without overlap. A platform is occupied from the start of the arrival minute to the end of the departure minute. Number of no two trains can use the same platform if their times overlap, even partially. Each train must be assigned a platform without delay. This insight will help RailQ prevent schedule conflicts. Right. So basically, we have to do some interesting calculations out here. I'll first create the database and then we'll get into this. So here we have two tables coming in. One is your train departures and second is your train arrival. So let's go and let's check it out. What all data we have in this. So here you can see that we have the train ID and we have the departure time. And same way here as well, we have the train ID and we have the arrival time. So these are the two tables on which we have to write our query based on the condition which is given. A platform is occupied from the start of the arrival minute to the end of the departure minute. No two trains can use the same platform if their times overlap, even partially. Each train must be assigned a platform without delay. Right. So what we'll do here is we'll first create one query, which will basically help me to create the arrival events. Right. So with arrival events, select train ID, arrival time as event time, one as platform change. From train arrivals. Select star from arrival events. right? So basically, this is the query which we have created, where for every train ID we have put the platform change. As of now, I just put this number as 1. We'll see what's the usage of this, right? Now I'll create the second query for the departure event as well. And will arrival means what? I need one platform, right? Train is arriving. And departure means what? I don't need a platform, right? So there I will make my platform change as -1. So departure events as select train ID, departure time as event time, -1 as platform change, right? And I will show you the data here. Select star from departure events. This from train departures, right? So here you can see that we are getting this -1. That means when the train is arriving, I am looking for one platform, and when the train is not arriving, or I can say when it is departing from the station, in that case, I don't need the platform. Now I'll apply the union out here, right? I'll combine this data which we have. So we'll create one more CT where I will union the events and sort uh, chronologically, right? So all events as select star from arrival events union select star from departure events, and I will make it union all, right? So these are the all events which we have. So select star from all events. So this is the combination of all the data which we have, right? Now what next we have to do? Now the next task is that I want to apply, I want to track the number of platforms in use at every point of time, right? At a given point of time, how many platforms are there and all those things, that information I want. So for that, I will create a query. So let's say running usage as select event time, sum of platform change over order by event time, rows between unbounded, preceding, and current row, right? This is my platform in use. I'll explain this query from all events, right? So now if I get out of this query, select star from running usage. So here you can see that we have what we have done here over the event time, sum of platform change over event time or order by event time. So if you see this time here, my data is sorted 8, 8, 5, 8, 5, 8, 10, 8, 10, 8, 10, 8, 15, right? And so on and so forth. And if you go, let me add one more thing here so that there will not be any confusion. Platform change, right? So see this. My data is sorted here based on the event time, right? So basically, let's say this train came in. Let me add the train ID also. That will be making more interesting thing. So train ID. So let me put my train ID at the start. So let's run this. So here you can see that my train ID came in. Okay. I assigned the value of platform change as 1. That's okay. It came at 8 p.m. 8 a.m. Sorry, 8 a.m. So at that point, this was my first train which came in, right? So at that point, I was requiring only one platform. My data is already sorted in the ascending order, right? From chote se bada. That means when this train will depart, right? Train ID number 1 will depart. That time will be smaller than bigger than the arrival time. My arrival time will always be smaller than the departure time, right? That's why when we are sorting the data, you can see here interesting numbers coming in. So this train ID 1 came in at 8 a.m. At that point of time, I need one platform. Train ID 2 also came in at 8:05 a.m. And at that time, I want 1 plus 1 because we are summing up right here. Some platform over order by. So we are summing up 1 plus 1 is 2. So 2 platform required at that point of time. Now 8:05 again, one more train came in. That is train ID number 3. So I need 3 platforms at that time. Then at 8:10, another train came in and I need 4 platform at a time. And again, train 5 came in and I need 5 platforms at a time. Now what happens is that train 2 departed, right? After 5 minutes, my train 2 departed. And as it departed, this number became -1. So now we are summing it up, right? So 5 minus 1 is gonna be 4. Now I need 4 platforms because one train already departed. Or I can say I have 4 platforms occupied as of now. Now at 8:15, what is happening is that this train number 1 is also going off from the platform. So what is happening? You can see that this is becoming 3. Same way, my train number 3 gone. So 2 platform required. 5 gone, 1 platform required, and 4 gone, 0 platform required. After that, again, some train came in. So I have the 3 platform required, again, 0 platform required, again, 3 platform, again, 0. So that is how the calculation is happening, right? Now, once that is done, what is my interest? My interest is that maximum platform in use, right? So maximum platform is what? 5, right? We'll check it out. So select max of platform in use as minimum platform required from running usage. So the minimum platform required is 5, right? So this is the entire query which we have built, which is basically giving me the understanding about how many platform at a single point of time is required, right? So what I did, I created the arrival gave the platform change as 1. I need one platform, and when the train is departing, I am making it as -1. After that, we are unioning it, sorting the data at the ascending order, and then we are summing the platform, right? So whenever it is 1, 1, 1, it is summing up 1 plus 1 is 2, 2 plus 1 is 3, and so on. And when the -1 is encountering, that means train is departing. So that occupied platform will reduce by 1. And this will happen. And I just wanted to know at a single point of time, what is the maximum platform we are looking for? So maximum number is coming out to be 5. If I go back to the problem now, it will make more sense. A platform is occupied from the start of the arrival minute to the end of the departure minutes. No two train can use the same platform if their time overlaps even partially. Each train must be assigned a platform without delay. Prevent That's it, right? That is what we need to find out. It's asking for a smart transportation analytical provider wants to optimize platform usage at busy train station to reduce delays and congestion. Given a day's schedule of train arrival and departure time, determine the minimum number of platforms required to accommodate all train traffic without overlap. And that is what we have solved here just now. Are you guys able to understand this query, all of you? Right, this is one of the tricky question, and I hope it is making sense. All right. Let's take one more question now. All right. Shop lens, right? Shop lens, a retail analytics firm, wants to monitor the reputation of new stores launched in the late 2021. Identify stores opened between July and December 2021, where more than 20% of the reviews are negative. A review is negative if the store is below 5. Output store name ratio of negative to positive reviews. This helps ShopLens quickly flag newly opened stores with potential customer satisfaction issues and prioritize follow-up actions. And so that is the requirement which we have. Let's try to solve this particular question. The very first thing which we'll do is we'll apply the filter on those stores which are opened from between July and December 2021. So let's do that. Select, okay, let me first show you the ID also, data also. Select star from Instacart reviews. Here you can see that we have the ID of the restaurant store, customer ID, store ID, and score, right? And if I go to the second one, here you can see that the ID. This ID basically is the store ID, right? And I want to join with this. One joins with this one, right? And so on. The common column is ID. So let's write the query first. We'll apply the filter on the store column, which is opening, right? Which is opening date between July and your December 2021. So with filtered stores as select ID, ID as store ID, name from Instacart stores, where opening date between this and this. That is your 2021-07-01 and 2021-12-31. So these are the stores which opened up between that particular dates. Select star from filtered stores, right? So these are the stores which opened up between that particular dates. Now what next I'm looking for? I'm looking for the reviews, and I want to tag them where the review is basically, what I want is, I want, if the review is less than 5, I want to tag it as it's a negative review, and or I can say I will tag it as 0 and 1, and I will say as one column as negative review and second column as positive review. So those stores which are having the negative reviews and positive reviews, I want to segregate that, right? So here I'll create another this thing subquery tagged reviews as select store ID case when score is less than 5, then 1, else 0. And as is negative. And same way, I'll apply one more case statement is positive. Right. From your reviews table. Let's give the alias as R. So here also I'll put R dot. Here also I'll put R dot, R dot. And I'll join this with my main table, which is the filtered records, because I'm interested in that stores only. So inner join filtered stores fs on R dot store ID is equal to fs dot store ID. Right. Let's get this data. Let's see how it looks like. Select star from tagged reviews. So here you can see that you are getting the store ID and the reviews. 0 means it's not negative, it's positive, right? And 1 means here it's a negative review and not positive, right? So for example, store ID number 1, there are 5 reviews. Out of 5 reviews, 4 reviews are positive, 1 review is negative. For your store number 5, all are positive. For your store number 2, all are negative, only 1 is positive, right? Store number 3, your 2 reviews are positive, 3 reviews are negative. And store number 7, your 4 reviews are negative, 2 reviews are positive. So that is the information we are getting here. Now I want to calculate the percentages. My end goal is to calculate the percentage, but before that I need to sum up these, how many positives and negatives are there. So we'll sum it up, is negative and is positive on group by store ID. So that is my review summary as select store ID. I'll sum up my is negative as negative count, and I'll sum up my is positive as my positive count, right? From my tagged reviews. Let's give this as R. Group by R dot store ID, right? Now when I write select star from review summary, you can see that we are getting the outcome. Store ID 1, I have 1 negative count, 4 positive count. Store ID 2, I have 0 negative count, 5 positive count, and so on, so forth. And now my task is simple, right? I just wanted to calculate the percentages. That is negative count upon positive count ka ratio. We need to find out, right? So let's do that. So let's create one more CT flagged stores as select name of the store, negative count divided by positive count. Now there can be a chance that my negative count can be 0, my positive count can also be 0, right? As of now, it's not there, but there can be a chance that I will have all negatives, 0 positives. So I just make sure that I will apply a null if, right? Null if positive count, comma 0, and I'll round it off. As negative to positive ratio. Negative count, positive count from review summary, the above CT, right? Let's give the alias as R. Inner join Instacart stores. Let's give this as S. On R dot store ID, because I need the name of the store as well, right? That's why I'm just introducing the S as well, the Instacart store as well. So R dot store ID is equal to S dot ID, where negative count is greater than 0 and negative count divided by negative count plus positive count. That is the ratio, right? So divided by this is more than 0.2, 20%. So select star from flagged stores. So here you can see that we are getting this this value, right? Now I'll just, that is fine. I think that is okay. So we got this number. Let me remove this condition for now, just to show you. So here you can see that you are getting what? 0.25 0, 4, 1.5 and 2. 0.2 is 20%, right? Here you can see we have one negative count and total is 5, right? 1 by 5 is how much? 20%. That's why it's not coming in. Because if you go and check the problem statement, identify a store opened between this and this where more than 20% of the reviews are negative. More than 20% of the reviews are negative. That is fine, right? Total reviews are 5. So how many are negative? Negative by total. That is 1 by 5. That is 20%. This is my negative to positive ratio. That is different thing, right? Don't confuse with that. This is my negative to positive ratio. That is 1 by 4. That is 0.25. But what is the total negative percentage? That is 1 by 5. Right? 0 by 5. 4 by 5. This is uh, 3 by 5. This is 4 by 6. Right? So basically, if I'll copy this thing as well and I'll put it here, you will get the idea. This number, right? This is my negative to total, right? So now I'm looking for those guys which are greater than 0.2. 20% reviews are negative, I'm okay with that. Less than 20%, I'm okay with that. But it is above 20%, these are the stores where it is above more than 20%. 80%, 60%, and 66%. So when I introduce this condition, it will only give me the last three records: Target, Costco, and Best Buy. So you can see Target, Costco, and Best Buy coming in because here the values are more than 0.2. All values are more than 0.2. Right? So these are the stores which are basically having the problem which we have to take care of. Right, so that is the requirement and this is how we implement it. Let's quickly go through this. We filtered the records, right, which is from July to December. After that, we went ahead and we, because the requirement was what? The requirement was if you go back to your reviews table, it was saying that if the score is less than 5, then it's a negative. And if it is more than 5, it's a positive. More than equal to 5, it is positive. So that is what we have written here. If the review is less than 5, you are 1 and is negative. And if it is more than equal to 5, you are 1, then it is positive. After that, we got the table where we summed up the total negatives and positives, because for negatives, I am getting 1 and for positives, I am getting 1. If it is positive, your negative will be 0. And if it is negative, your positive will be 0. So when I sum up, it will sum up all the negatives and sum up all the positives. Once we had that, we went ahead and joined with the main store table to get the store name. We calculated the negative upon positive ratio. We calculated the negative upon total ratio as well. And then we went ahead and mentioned that we are looking for negative count more than 0 and negative upon total will be more than 0.5, 0.2, sorry. And once we ran this query, we got this output that these are the stores which are having more than 20% of the reviews as negative. And these stores we need to highlight. Are you guys clear with this, all of you? This problem statement. All right, let's take one more last example today. What about rest of the folks? I see 2 responses. There are 8 learners out there, 7 learners. Rest all are sleeping. Are you getting it or not? Not getting, let me know. I'll explain it again. Three responses. What about others? Tejaswini, Sonu, Priyanka, Naman. Good morning. Let's explain this again. I'm not sure you are understanding or not. Okay, I'll do that. तो पूछो ना फिर कौन मना कर रहा है? Till the time you will not able to help me understand your understanding or not, how will I help you understand what's going on? इसके पहले वाला क्लियर है, ट्रेन वाला कि नहीं उसमें डाउट है? ट्रेन वाला इज फाइन ऑल ऑफ यू, द ट्रेन एग्जाम्पल. No problem. This is my ID, customer ID, store ID, and score. This store ID you can ignore. That's okay. So ID, customer ID. Let's remove this. No need. And there's the score. Okay. My second table is Instacart stores. These are the 7 stores which we have. Store ID, store name. This is a zip. We don't need that, so we can remove. That's okay. And this is the start date, opening date. Okay. So these are the 2 tables which we have. Now let's come back to the query. What we did, let's try to understand. The very first thing which we did is we only use the stores table and we filter out on those stores which opened up between 1st July to 31st December 2021. So here this guy is satisfying the criteria. This guy is satisfying the criteria. Satisfying. This is not satisfying, right? Store number 4, I don't need it because it is in the month of June. 7-Eleven is okay. This is also not valid because it's 2020. I'm looking for 2021. So these are the 5 stores which opened up. So the first query was doing what? The first query was just giving me the stores which are opened up in that particular this thing, date range, right? So that is the first part. Now we went to this second query where what we are doing is that I am joining my Instacart review with the store because my interest is on those store only. And wherever I am getting the score less than 5, I am assigning a new column as is negative and giving the value as 1, is positive, giving the value as 1. So basically 1, 2, 3, 5, 7. So my interest in this particular data, will be on 1, 2, 3, 5, 7. That means 6 and 8 are of 1, 2, 3, 5, 7. 9 is also I don't want, right? What is this? Yeah, that's okay. So these are the stores, right? I joined on which column? Let's quickly check. Store ID equal to store ID. Instacart reviews. Just give me a second. This is my ID. Ah, okay. Store ID, right? This one. Okay, this is the surrogate key. That store ID is important for us. I got confused here, right, with this ID. So let me insert this and I will have the store ID. This ID is of no use. We can remove this. Let's run it. Okay. So now I will join one with one, one with one. Now what I'm saying is that if you go back to the query, if the R square is less than R dot score is less than 5, then I will make it as 1. So basically I'm creating two new columns. One is negative and is positive. Right. And here I will apply this on all the stores which I'm interested in. 6 I don't want and 4 I don't want, right? I only want 1, 2, 3, 5, 7. So these two stores, 4 and 6, are of no use. So I can very well remove this data. Undo, 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 undo. So 4 and 6 I don't want. Right. So these are the stores which I'm interested in. So now is it less than 5? No, it is not. So this will become 0. This will become 1. Right. So wherever it is less than 5 will become negative, will become 1, positive will become 0. So this is also 0, 0, 0. This will become 1. This will become 0. This will become 0. This will become 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 1, 1, 1, 1, 1, 1, 1, 0, 0. Right. So that is how we assign the value. Same way here also. If it is 0 here, so it will be 1, right? Because वो negative नहीं है तो positive होगा. So 1, 1, 1, 1, 0, 1, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 0, 0, 0, 0, 0, 0, 0, 1, 1. That's it, right? So this query is doing what? This query is just doing the same thing, right? It is assigning 0 or 1 based on the score. If score is less than 5, it will be 1, else 0, right? If the score is less than 5, it will be 1, for is negative, else 0. Else means for 7 it is 0. Same way for positive as well. If it is more than equal to 5, you are 1. If it is less than 5, you are 0. So that is what we did here, right? After that, we are summing up is negatives and is positives for every store, right? We are grouping on the store ID and summing it up. So now what I'm doing, I'm grouping on the store. Sorry, store. Let's say store ID number 1. So in store ID number 1, we have 1 negative, 4 positive, right? So I have the store ID number 1, 2, 3, 5, 7. And I have the total negatives and total positives. So I have 1 negative and 4 positive, right? इसका sum करेंगे तो 1 हो जाएगा, इसका sum करेंगे तो 4 हो जाएगा. Now same thing I will do for the second store. 4 negative, 1 positive, right? So 4 negative, 1 positive. Same way I'll do for the third store. 3 negative, 2 positive. 3 negative, 2 positive. For store number 5, all are positive. How many? 5. 5 are positive. And for store number 7, 4 are negative, 2 are positive. 4 are negative, 2 are positive. So we got this information. Till this point, it is making sense, all of you. What's going on? All right. Now, what I want is I am calculating two ratios. First ratio is negative by positive, and second ratio is negative by total. Right. So, what is negative to positive? That is nothing but 1 by 4. And same way, what is negative to total? That is nothing but negative by negative plus positive. Right. So these are the ratios which we got. Now, what is my interest? My interest is that where your negative by total is more than 20%. Where negative by total is more than 20%. I am looking for that store. So store number 2, store number 3, and store number 7 is a problematic store. Store number 2, 3, and 7. And when we were running this query, we are getting the same store number 2. Target cost. Target is what? Target is nothing but your store number 2. Costco is what? Store number 3. And Best Buy is what? Store number 7. So 2, 3, and 7. Clear? So that is how we solve this problem, and I hope it makes sense now. All right. So let's go to the next one, which we have. Cineplan, a theater scheduling system, wants to optimize pair bookings by identifying adjacent available seats. Find all distinct pairs of available seats that are also adjacent based on the provided neighboring seat data. Only consider seat pairs where both seats are available. Output pair as sheet 1, sheet 2, such that sheet 1 is less than sheet 2, not sheet, but seat 2, to avoid duplicates. Seat 1, seat 2. Each pair appears only once, ordered by seat number. This insight helps Cineplan suggest better seating arrangement for couples or groups. So let's first see the data what we have. So we have two tables out here, theater seat map. So here you can see that seat number 11, seat towards left, there is no seat towards left. Yes, but towards right, there is a seat number 12 is there. For seat number 11, the right seat is 12, right? That means for 12, the left seat is 11. So for 12, the left seat is 11 and right seat is 13. Same way for 13, left seat is 12, right is 14, and so on, so forth, right? For example, here, 31. So you can actually create a diagram and you can understand as well. So 11 is there. There is no left seat, but right seat is there. That is 12. 13 is there. 14 is there. 15 is there. For 15, there is no right seat, right? So 15 is there is no right seat. Left seat is 14. So 5 chairs साथ में. Now the new line starts. That is your 21. There is no left seat, so 21. 22 is the right seat. 23 is the right seat. 24 is the right seat, and 25 is the right seat. After 25, 25 ka left 24 hai, but there is no right. So this is my 5 seats. Same goes with 31. So 31, 32, 33, 34, and 34. So these are the seats which we have. Okay. Now let's go to the second table. Theater availability, right? Now here 0 means not available, 1 means available. Is available, 1 means yes. That means 12 is available, right? So whichever seats are available, let's highlight in blue. So 12 is available, 13 is not, 14 is available, 15 is also available, right? 21 is available, 22 is available, 23 is available, 24, 25 is not, right? 31 is not, 32 is available, 33 is available, 34 is not, 35 is. So this is the pair which is available, this is the pair which is available, and this is the pair which is available. Okay. So let's remove this diagram for now. Let's write the query. Then we'll come back to the same diagram. So what is my interest here is, my interest is that I will first get the available seats, right? So with available seats as select seat number from theater availability where is available is equal to 1, right? So it is gonna give me all the available seats. Right? So these are the available seats. Let's come back to the diagram. So 12, 14, 15, 21, 22, 23, 32, 33, and 35. Right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 seats. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 seats are available. So that is looking fine. Now, I am looking for adjacent seats, right? So let's create the next CT, that is adjacent pairs. So adjacent pairs as, now select, I will join my seat map table with the available seats table, right? So select seat number as seat 1. Seat number, I'll explain this. Seat number, or I can say seat right as seat 2. From theater seat map SM. Let's say this is my seat right is SM. And this guy, let's give this as S1. That is available seat. I'm creating another table, or I'm joining another table. Inner join available seats. That is my S1. On SM dot seat number is equal to S1 dot seat number. Inner join, again available seats, S2 on SM dot seat right is equal to S2 dot seat number, where SM dot seat right is not null, right? Select star from adjacent pairs. Let's come back to the picture first. 14, 15 adjacent, 21, 22 adjacent, 22, 23 adjacent, and 32, 33 adjacent. Looking perfectly fine. Now let's understand what happened actually. Let's come back to your this thing, store seat map, right? This is my data. Let me copy this. Okay. So this is my seat number, left seat, right seat. This is my seat number, seat left, and seat right. And second is available seats, right? So your this one. These are my available seats. Okay. Now let's come back to the query which we have written. So what I'm doing, I'm joining on the theater seat map and the seat available seats. I'm joining these two tables, right? Now on which column I'm joining? I'm joining on sm dot seat number. SM is seat map, the main table. Sm dot seat number, this column with available seat number, right? Available seat number. That is nothing but this number only. So I'm joining this and this, right? And second condition, what we have written. So here, if you see, sm dot seat number is equal to s1 dot seat number. Inner join, again you are joining with the s2, same table. Again you are joining with this table. Let me create a copy of this. Again you are joining this. Let's give this color as different. And you are joining with what? You are joining with sm dot seat right. Sm dot seat right is equal to s2 dot seat number. This one, right? So we are joining this and this, and joining this and this. Now let's come back to the query. And also you are saying sm dot seat right is not null. Sm dot seat right is not null. That means this guy I will not consider. This guy I will not consider, right? Because that is the end. 35 के बाद कोई right में है नहीं इसलिए, right? So that these three records will not participate. Okay. Now let's do the join and let's see what is happening. So 12 joins with 12, right? 12 joins with 12. And what in the select you are calling? You are calling S1 dot seat number and SM dot seat right, right? That is what you are calling in the select S1 dot seat number and SM dot seat right. S1 means this one. So S1 dot seat number, that is 12, and seat right, that is 13, right? 12, 13. These are the available seats, right? And 13 is what we are checking. So you will get this record 12 and this guy joins. This is coming in. Now in the second join, what you are doing is sm dot seat right is equal to seat number, right? Sm dot seat right is equal to seat number. Sm dot seat right is 13 is equal to seat number. Do you see any 13 out here? No, I don't see that. So 13 will not be coming in. And if 13 is not coming in, obviously adjacent seat is not there. So this guy will not come. Now we'll check for 14. 14 joins with 14. Right seat is 15. Is 15 available here? Yes, available. So in that case, you will get 14 seat number and 15, right? 14 and 15 coming in. Then 15 joins with 15. It's not there, so it will not participate. That's okay, right? Because we mentioned that this guy should not be null. 15 is present here, but this guy is null, so it will not join. Because there is no adjacent seat for it. After 15, there is no adjacent seat, right? So that's why it's not considered. 21 joins with 21. 22 is the seat number. 21 and 22. But is 22 present here? Yes, 22 is present. So this combination is also coming in. Now 22 joins with 22. Right seat is 23. 22 and 23. Is 23 present here? Yes, present. So that combination is also coming in. 23 joins with 23. 24 is 24 present. 24 is not present. So that combination will not come. 32 joins with 32. 33 is 33 present? Yes, present. So 32, 33 combination coming in. Same way 33 joins with 33. 34 is 34 present? No, it is not. So that will not come. 35 joins with, there is no 35. So that's it. So I should get a combination of 14, 15, 21, 22, 23, 20, or 22, 23, and 32, 33. So let's see what is coming in. 14, 15. Right? 14, 15 coming in. 21, 22, 22, 23, and 32, 33. So those combinations are coming in. Is this query making sense, all of you? Basically, I am checking the left seat also and right seat also. Here you can see I am joining the seat number with the seat number, and then I am checking the right seat as well, whether right seat is available or not for adjacent thing, right? All right. So I'll share these queries with you, right? I'll share it with the support team and they will forward it. So we'll see you again next time. Till then, do practice.